Chapter 9 Applications of Integrations. Example 9.22. The question is, show that integral 0 to 2 pi g of cos x dx equal to 2 times 0 to pi g cos x dx. The question is, show that 0 to 2 pi g of cos x dx equal to 2 times 0 to pi g of cos x dx. Solution. We know that on property 0 to 2a f of x dx equal to 2 times 0 to a f of x dx. If f of 2a minus x is equal to f of x. We know that on property 0 to 2a f of x dx equal to 2 times 0 to a f of x dx if f of 2a minus x is equal to f of x. The condition after if is true, the first part also true. This is the first part. The first part is true when f of 2a minus x is equal to f of x. First, we check the condition f of 2a minus x is equal to f of x. So, we start with f of 2a minus x. In our question, our 2a is 2 pi. Therefore, here 2a is equal to 2 pi. That implies our a is equal to pi. Starts with left hand side. It is f of 2a minus x is equal to f of 2a is 2 pi minus x. F of 2 pi minus x. But our f of x is equal to g of cos x. Replace, so now f of 2 pi minus x. Therefore, replace our x by 2 pi minus x. So, our f of x is g of cos of x. Therefore, g of cos in the place of x, substitute 2 pi minus x. It is 2 pi minus x. This is equal to g of cos our 2 pi. So, 2 pi is equal to 360 degree. We know that our 360 degree is coincide to 0 degree. Our 360 degree is coincide to 0 degree. Therefore, not necessary write 2 pi, just write minus x. So, we know that cos of minus x is a cos x because it is a given function. G of cos x, this is equal to f of x. Therefore, note that f of 2a minus x is equal to f of x. Therefore, the condition after if is true. Therefore, the first part also true. So, first part also true. Therefore, we can write the first part 0 to 2a f of x dx equal to 2 times 0 to a f of x dx. Just replace 2a by 2 pi. So, we get 0 to 2 pi. 0 to 2 pi f of x is g of cos x. g of cos x dx equal to 2 times 0 to our a is pi, g of cos x dx. So according to this property, we get the result 0 to 2 pi g of cos x dx equal to 2 times 0 to pi g of cos x dx. Therefore, this result is proved. The result is proved. Question number 9.22 over. The question number 9.22 over. We move to question number 9.23. Example 9.23. So now, let's see the example 9.23. So the question is, if f of x equal to f of a plus x, then 0 to 2a f of x dx equal to 2 times 0 to a f of x dx. So one more time read the question. If f of x equal to f of a plus x, then integral 0 to 2a f of x dx is equal to 2 times 0 to a f of x dx. Solution. So in our question, the given thing is f of x equal to f of a plus x, and we need to prove 0 to 2a f of x dx equal to 2 times 0 to a f of x dx. So given things are f of x is equal to f of a plus x, and we need to prove 0 to 2a f of x dx is equal to 2 times 0 to a f of x dx. First, we start with the left hand side first. So our left hand side is equal to 0 to 2a f of x dx. Our left hand side is 0 to 2a f of x dx. This is equal to, so consider a number line. So consider number line, here 0, here a and 2a, and moving. This 2a, 0 to 2a, this 0 to 2a can split into two intervals, 0 to a and a to 2a. Therefore, according to the number line, so we divide the given integral as a two sub-integrals. So the 0 to 2a is divided into two sub-intervals. So therefore we get 0 to a f of x dx plus and a to 2a f of x dx. Now consider this term, consider the second term. Now consider the second term. First consider the second term. Consider a to 2a f of x dx. So put our x is equal to a plus u. So now differentiate with respect to x on both sides. We get differentiation of x is 1, differentiation of constant is 0. So u is du by dx. Therefore, du by dx equal to 1. Just cross multiplying it, we get du is equal to dx. So d is equal to dx. Now change the limit from the variable x to the variable u. So from the variable x to the variable u. So from the table, the given variable is x, our changing variable is a u. So the limit of x is a2 to a. The limit of x is a2 to a. So here x is equal to a plus u. A plus u. If x is equal to a, this term a equal to a plus u. That is a minus a is equal to u. We get u equal to 0. Here substitute 0. If x is equal to 2a, substituting here we get 2a is equal to a plus u. From that line we get 2a minus a is equal to u. Therefore u is equal to a. Here 0, here a. Substitute here as a. Therefore the limit is changing to 0 to a for the variable u. So now that integral becomes 0 to 2a f of x dx equal to 0 to, here the integral, given integral is a to 2a. Therefore our given integral a to 2a f of x dx equal to, so a to 2a f of x dx is equal to 0 to a f of, for the place x, substitute a plus u. So f of a plus u dx is equal to du. Here du. Now in our question the given result is f of x is equal to f of a plus x. According to that result, here we write 0 to a f of a plus u, that is equal to here f of a plus x, f of x. Therefore f of a plus u is f of u du. In next line, just replace u by x. We get 0 to a f of x dx. Therefore the a to a f of x dx result is equal to 0 to a f of x dx. Here note that this line is a number one equation. The result, we get the result as a number 2. So substitute 2 in 1. Substitute the result 2 in 1. We get, the left hand side is 0 to 2a f of x dx is equal to, the first term is 0 to a f of x dx plus the second term is 0 to a f of x dx. Here look the integral limits for the two terms, they are same. So 0 to a, here also 0 to a. So just write one time 0 to a, or both are same terms, 0 to a f of x dx plus 0 to a f of x dx. So we can write 2 times 0 to a f of x dx. This is equal to 2 times 0 to a f of x dx. Therefore the 0 to 2a f of x dx is equal to 2 times 0 to a f of x dx. So our result is proved. Therefore our result is proved. For example 9.23 is also over. Example 9.23 is also over. Thank you.